Hello, today our group will present our project. This project names RPG games use Spider FSM. And this project combines autonomous Spider agent, a finite state machine controlling the game, and a lighter weight RPG game battle system. My name is Pen.
And my name is Li Xiaotong.
My name is Yao Ruiyang.
So now I'm going to briefly explain the code and demonstrate how the game runs. So our game is organized around a single Spider agent. Inside this agent, we attach an FSM behaviors. You can see in the end of the code. So here, this is a FSM. And our entire game has six status. So first status is start, and the second one is exploration, and the third one is combat, and the first one is level up. If the player uh, defeats the boss, then it's going to the end state. And now Xiaotong will introduce class player.
Yeah, before going into the FSM, we first define our character classes. The first class is player. The player object stores HP, attack power, level, experience, and number of wins. When the player takes damage, we simply reduce HP but make sure it doesn't go below zero. We also include a helper function to check if the player is still alive. And the second class is monster. The monsters have different tiers, the tier 1 goblin, the tier 2 orc, and the tier 3 demon. Their HP, attack, and XP reward increase with tier. We also create a boss class inherited from monster but with much stronger stats. This keeps our code clean and avoid repeating logic. And then the start state simply initialized the game. It prints a title, creates the play object, and displays initial states. Then immediately transitions to the next state exploration. This mirrors how many RPG games begin, introducing the player and setting the stage. In Exploration Station, the agent shows the current HP and level and win count. Based on the player's level, it decided the difficulties of the monster. For example, the level 1 is the Goblin and the level 2 and up is to the Auric. And after spelling a monster, the FSM moves structurally to combat. Think of this as entering a room and seeing a monster appear.
Okay, now I'm going to introduce the combat state. Okay, this is a complex state and very interesting. So when the player enter this state, it's going to um, uh, print attention. Yeah, combat. The monster is coming, and here this is characteristics of the agent. So when they use this one, so they can get the data from the whole agent. It's very important for our game. So when here, this is the while loop. It means the monster is still alive and the player also still alive. Here, this is the damage. The damage generated in random. So we use a random function here. And the monster will be hit. This is the damage from the players. And then check if the monster still alive is going to I mean if the monster not still alive, it means the player has already defeated the monster. So it's where the players experience will increase, and the winner number will increase too. And here it means if the experience greater than 50, it means the greater will increase their level. So such as increase from 1 to 2, level 1 to level 2. And if not, is the player will going to explode, and then they will meet other monsters. And about monster attacks, the same as the damage of the player. Monster damage also generated in random. So here where it will print the attacks from the monster, and will tell you the specific number over here. And if the player is still alive, is okay. I mean, if the player was defeated by the monster, it means the player was dead. So it will enter the final state. This is the end state. About a level up state, it means the player levels up, and they has enough like experience about that. So when they get more than 50 experience, then their level will rose up, and their blood, I think is it HP, will increase also. Here their ability of attacking also will increase. And then this code means it's going to print the specific content. If their level and the winner number reach a specific number, like the level more than 3 and the winner number more than 4, is we're going to touch it will going to meet the boss. The boss will coming. And if not, they were going to continue to explore some monsters. And the boss fight state, this state almost the same as the monster state, this one. So briefly introduction, the boss has a great attack here, you can see. And then it means the player will get a higher damage from the boss. And now Yao will introduce the end state.
Yeah, we now reach the final state of the FSM in the end state. This state is responsible for displaying the game results and shutting down the engine. When the end state is executed, it print game over and check whether the player defeat and the final boss. If self-engine victory is true, the player has won the game. Otherwise, the player was defeated. Finally, it prints the player's final stats, including level, HP, and the total wins. After displaying all results, the engine stops the game ends completely. Next is the main game engine. Inside it, we define the game FSM class, which is a finite state machine controlling the entire game flow. It prints messages when the FSM starts and ends. In the setup method, we initialize the shared variables such as the player, the current monster, and the victory flag. We then create an FSM behaviors instance and add all 6 game states. We also define all wide transition between state. For example, the combat state can transition to level up, explosion, and others. Finally, the FSM is at the engine so that it can run automatically below the behavior logic. Uh, we have programmed enter point main. Here, a game engine is created and start using an Azure XMPP account. Once the engine starts, it automatically runs according to the FSM law. Yeah, that's all.
Yes, thank you for listening. Now I'm going to run this program. Wait a second. Wait a second. I built this program in visualized environment. So firstly, I should activate this environment. And right, this desktop. I'm going to run this program. Wait a second. Coming. So here, let's FSM again start. And here the first hero is coming. The HP, attacked ability, and the first. Yeah, this is the exploring stage. The goblin monster appears. So this is the information of all of this monster. Then this is a combat stage. I attacked and the damage. What is that damage? And now after I attacked the goblin, and his HP become to 25 from 45 to 25 because goblin receive 20 damage from the player, and then until the goblin HP to 0, this means goblin defeated, and I got to the XP. It's almost 25, and because the player didn't reach the layup level. Because if you wanted to level up, you should reach more than 50 EXP. So now it's only 25. And then going to another exploring. So here you can see the player HP is 17 instead of 100 because the player was attacked by the goblin in the first exploration. And then here you can see the result. The result here, the goblin defeated again, and then the player got 25 XP again, and also the player get the the player can level up because the player has almost 15 XP here. Then level up stage over here, and then when they when the player level achieved at 4, and when the player has won for 4 games, the boss travel ahead and then fight with boss. And finally, you can see the result. Game over. It means I was defeated by the boss, so I didn't win this game. So the final stage is now I'm level 4, but the HB is 0, even though I win 4 games. So this is because I use the random function, so now I'm going to run it again to explore another opportunity to fight with a boss. Yes, it's coming. Start station, start state, exploring state, combat state, exploring combat, level up, and combat again, level up again, combat again, level up again. Boss fight is coming. Oh my god, then I defeated by the boss again. But this is almost different. The damage is 24, 3. This is 30, so it's randomly, right? So unfortunately, the player has lost again twice. Okay, this is all for our presentation. Thank you for listening.